Hi and welcome back. So in this video I'm going to talk about a linked hash map. So linked hash map is a kind of hash map, as the name specifies, that uses a doubly linked list to store all its entries. So why it uses a doubly linked list? So it uses a doubly linked list because it wants to retain the ordering of the keys that you added to it. So it doesn't rearrange the keys of this map. So as in my previous videos, I talked about a hash map and the tree map. They reorder the keys. They won't retain the order in which you added them. A hash map changes is based on the hashing algorithm, and a tree map based on your sorting method you provide to it, or in the natural ordering if you don't provide anything to it. So, but a linked hash map maintains that order. So that is why a linked hash map is used. So let's see this in action. So I already have on screen, I'm gonna correct this, a linked hash map created, and I'm gonna add some values to it. So I'm gonna add my first value A and give it integer 1, my next key B, and I'm gonna give it a value 2, and my last key and give it a value 3, and I'm gonna print this map on the console. Wait a sec. I'm gonna print this map on the console to see if it retains the ordering, and you can print it just like that. Save it, and as you can see, the keys are in the same order in which we added them. So this is why mainly the linked hash map is used. So I'm going to talk a little bit about the maps besides this, and these things are applicable to all kind of maps in Java. So mostly to add the keys to a map, it's much safer to use putif absent. Because if you use this and the key is present in the map, it won't override the existing value to it. So let's print out the map again. So in this case, the B will retain its values, which was 2 previously, and usually use this method because sometimes we don't realize and we override the old values. So if I change this back to just put and print it out, it gives back me the overridden value. So it's usually safer to use the putif absent. So make that a practice. So another thing is, if I iterate through the map and try to remove the keys while doing so, I'm gonna go through each key of the key set, and if A equal ignore case matches to any key of the map, I'm gonna say remove it. Remove this key, and what we're gonna see is an exception. So before that, A equal ignore case mappy dot, oops, I made a mistake here. If this key equals to A, then try to remove that key from the map. So it gives me a concurrent modification exception. So what this means is I cannot change the map, actually cannot extract from the map while iterating through it. I can't do a concurrent modification to it. So to remedy this, there is another method on the map which is called remove if present. So on the key set, there is a method, it's called removeif, and this is gonna give you a key, and we're gonna add a lambda expression saying the same thing. If key is equals to A, then this is gonna take care of removing it, and this is gonna return a boolean value because removeif takes in a predicate Let's inspect this one. Where did the inspect go? Can't find it right now. I'm just gonna hover over it. It's gonna show me that it's gonna be a predicate of type string. So it's gonna take in a string and return a boolean value. So once it says true, it's gonna remove that key from this map along with its value. So if I'm gonna print this one, save it. So I'm gonna be left with the two keys and values in the map, basically two entries, which are these two, and this entry will be removed. So yeah, that's it about the maps. So hope to see you in the next videos. Bye.